Now let's try to understand pointer arithmetic, right? Very important concept to understand once again. Pointers can be incremented or decremented, which moves them by the size of the data type they point to, right? The basic idea is that I can basically like increment pointers to get another value, right? I think this would be easier to explain with this code example. So let's try to take a look at this code, right? Basically what I'm doing is, first of all, I am declaring an array of the size 3 and I'm storing the values 10, 20 and 30 inside it, right? Second thing is I am creating a pointer to this array, right? And then I'm printing the value. So let's try to understand what exactly is happening, right? When I create this integer array of 3, right, it's going to create these 3 blocks of memory, right? So this is what it's going to look like, right? Let's say this is what it's going to look like inside the memory. So this array, at each different address, we would have 10, 20, and 30. One very important thing to understand is that one integer usually occupies 4 bytes, right? So how the addresses would actually look is kind of like this. So if this is 0x6000, this would be 0x6004, and this would be 0x6008, right? So this integer 10 would actually occupy something like this. Right? So let's try to understand what this means, right? So this 10, this array would actually start at the address 0x6000, right? So it would occupy the space from 6000, 6001, 6002, and 6003, right? This is how much space this 10 would actually need inside the memory, right? After that, from 6004, we would store 20. That would again occupy 4 bytes. And after that ends, we would have 30 at the address 0x6008, right? I hope you are able to understand this. If it's kind of complicated, don't worry too much about this part. But let's try to understand that since it's an integer requires 4 bytes. That is why they are separated by 4 spaces in this example, right? Okay, let's try to understand what's exactly happening. So I create this integer array of three integers, right? Which means in total I would need 4 into 3, right? 12 bytes, right? I create a pointer int star p equal array. So let's try to understand what happens when I do this. So the thing is that this value ARR, right, is actually the address to the first value inside our array, right? So this is actually going to be 0x6000, right? So whenever you create an array, remember that if you just print that value, that would actually be the address to the first element inside the array, right? So in this example, let's say if our array starts at the address 0x6000, then ARR would actually be equal to 0x6000, right? So let's try to understand what happens in this case. So when I print int star p equal ARR, this would set p equal ARR, which is equal to 0x6000. So in very simple words, now my p, this value p would actually point to that address or point to this array over here, right? Second thing I do is I print %d star p, right? So let's try to pause the video and try to understand what exactly would be printed. Okay, so if you're able to understand it, this star p, since it refers to the address 0x6000, the first value stored is 10, right? So it refers to the, actually points to the first value inside the array. So this print statement over here would actually print the value 10, right? I hope that makes sense. Why? Once again, let's try to understand it. ARR actually is the address to the first element, right? In this case, it would be 0x6000. So when I dereference the pointer and print it, it would give me the first value, which is 10, right? So, but the point of the video is that pointers can actually be incremented or decremented. So now what happens is when I increment this pointer, right, it increments the pointer or the address by the size of the data type we have. So in this case, when I do p++, this would basically do 0x6000 plus 4, which is equal to 0x6004. In very simple terms, what it would do is it would go from this 10 to the 20 over here, right? So P++ would basically move whatever that data type requires, right? How much space that data type requires. So since integers require 4 bytes, it's gonna move ahead by 4 bytes inside the memory. So now the address would actually point to the value 20 inside the memory, right? So what would this print? This over here, the statement would actually print 20 over here, right? If I do p plus plus one more time, let's say I do p plus equal 1. When I do plus equal 1 one more time, it's going to increment the pointer again and it's going to move to the value 30. But remember the addresses, this would be added by 4, which would give me the new address 0x6008. Right? It's not incrementing by 1, it's actually incrementing by the amount of space that the particular data type requires, right? So another example would be, let's say if the data type was a char, right? Chars usually occupy just a 1 byte. So if let's say I have a char array equal, let's say A, B, C, right? Let's say I have this char array A, B, C, right? These would actually occupy just single bytes. So this is what it would look like, right? In the memory, we would have A, B, C. This would be 0x, let's say 7000. This would be 0x7001. And this would be 0x7002. Right? So in the memory, there would be just 1 byte after the other. And since integers require 4 bytes, they are separated by 4 bytes, right? So I hope the pointer arithmetic makes sense, right? Now let's try to understand some other concepts.